Hi everyone. In this video we're going to learn some of the important things about polynomials as far as vocabulary and concepts so that we'll all be on the same page as far as what we're talking about as we study these types of functions. A polynomial is a term or finite sum of terms with only positive or zero integer exponents permitted on the variables. Remember, finite means not infinite, so no dots. It has to stop somewhere. And that means we're not allowed to have negative exponents, fraction or decimal exponents, variables in the exponent, or variables in the denominator. Also excluded are irrational exponents. The degree of a term is its exponent. For example, the term 4x to the fifth would have a degree of 5. So, let's say we have a polynomial and we want to find its degree. Take this polynomial, 10x squared minus 2x to the fifth plus 55x, for example. In order to figure out the degree, first we need to look at the dominating term. The dominating term is the term with the highest exponent. In this polynomial, the dominating term is negative 2x to the fifth. The exponent of this term tells us the degree, so the degree of this polynomial is 5. The coefficient of this term is the polynomial's leading coefficient, which means that negative 2 is the leading coefficient for this polynomial. The degree and the leading coefficient are going to be very important in being able to predict how a polynomial function will behave. So, a polynomial function is a polynomial of the form p of x. They could have used f of x too, but they just decided to use p for polynomial. And now you're looking at all of these letters and subscripts and superscripts and probably freaking out. Don't freak out. Let's just say n was 10 and it was a 10th degree polynomial, or an x to the 10th. All that would mean is it could look like some number, say 3, x to the 10th, plus another number, say 5, x to the 9th, plus and so on, x to the 8th, x to the 7th, all the way down until you get to a linear term, and then a constant term without a variable. So don't freak out. All this is the standard form. And how polynomial functions are usually written is with the exponents in descending order. One of the common ways to write a polynomial is in the standard form. Standard form is really useful because it makes it really easy to tell a polynomial's degree and leading coefficient. In order to be in standard form, all factors must be multiplied out. The expression 2x times quantity x squared plus 2x minus 4 is not in standard form. In order to write it in standard form, we could distribute out the 2x and then collect any like terms. So 2x cubed plus 4x squared minus 4 would be that expression in standard form. Also, all the like terms need to be collected. So 4x squared plus 6 minus x squared is not in standard form because there are two x squared terms. The standard form would be achieved by collecting the 4x squared and the negative x squared to make 3x squared plus 6. Finally, the terms need to be in descending order of degree, or in other words, from highest exponent to lowest exponent. So 3x cubed plus x to the fifth plus 2x is not in standard form. If I rearrange the terms as x to the fifth plus 3x cubed plus 2x, now the exponents are in order from highest to lowest, and therefore the polynomial is in standard form. To help us talk about polynomials, especially some more common ones, a lot of times we name them by their degree and by their number of terms. A lot of these terms should look familiar based on what you know about words and based on what you know about some of the functions you've already studied. A polynomial of degree 0 is constant because x to the 0 is 1, which would mean that it would only have a number. A polynomial of degree 1 is linear. That's like x plus something. That should make you think of y equals mx plus b and make you think of lines. Quadratics we spent a good deal of time with last semester, x squared. Cubic, 3-dimension, should make you think of cubes. Quartic, think like 4 quarters in a dollar or 4 quarters in a game. And then quintic, like when someone has 5 babies at the same time, they're quintuplets. Anything after 5 stops having special names. So it'll just be 6th degree, 7th degree, and so on. We can also name them by number of terms. 1 term would be monomial, 2 terms would be binomial, 3 terms would be trinomial, and everything else is just a polynomial of however many terms it happens to have. So for example, 3x to the fifth minus x, this would be a quintic binomial. Quintic because it has degree 5, and then a binomial because it has 2 terms. The last important thing to consider about polynomial is extrema. An extrema basically looks like a turning point on the graph. Extrema can be classified as maximums or minimums based on whether they are higher or lower than all of the points around them. Extrema can also be classified as absolute or global, or as local or relative. Absolute or global extrema means that it's going to be either the highest or lowest point on the entire graph. For example, the point highlighted in blue is an absolute minimum because it's the lowest point on the entire graph of the function, and circled in red is an absolute maximum because it's the highest point on the entire function. Local or relative extrema are just the highest or lowest point of all of the points around them. For example, if you were to draw a box around this part of the graph, as I showed in the light blue, this point here would be the lowest point, therefore it would be a local minimum. It's the lowest value in that local region. It's also where the graph turns around. You'll notice on the left side the function is decreasing, and on the right side the function is increasing. So highlighted in light blue are all the relative minimums, and highlighted in pink are all of the relative maximums. All absolute extrema are also relative extrema. Just all relative extrema are not necessarily absolute extrema. Also, notice that it's possible for a graph to not even have any absolute extrema at all. Polynomials are really interesting functions to look at. Now that you've learned some of the basic terms about them, we'll be able to explore all of the different and interesting properties that they can have.